right, so our next speaker is Waris Gill from the University of Virginia Tech, and he will be talking about a new framework, TraceFL, for debugging in federated learning. So can you just test the audio just to see if everything's set up properly?
Yeah. Hello, everyone.
Yeah, perfect.
Yeah, perfect.
I'll let you the floor.
Okay.
Go ahead.
Thank you. Hello, everyone. I am Waris Gill. I am fourth-year PhD student at Virginia Tech. And today I will present TraceFL Interpretability-Driven Debugging in Federated Learning via Neuron Provenance. So suppose we have 6 hospitals and they are training different models based on their data. And as we know, in federated learning, we have different data distributions. Now, let's suppose we aggregate this model. Let's say we are using Fed average, and on the central server, if this model makes a prediction, so the key question is which client is basically responsible for this prediction. So as we know, this a global model is not directly trained on any data. And no preferred solution is available. So there are a few challenges which we need to address while enabling debugging and interpretability in federated learning. So the first challenge is we do not have access to direct client data. For instance, in this case, we cannot directly, if we are sitting at the central server, we cannot go and inspect the hospital's data. The second one is the global model is not trained directly on any data. So the third one is all the clients not participate in every federated learning round. And as we know, the clients have different data distributions. So this is another challenge. And the existing ML interpretability techniques are inadequate in federated learning because they focus on different set of problems. For instance, if they try to understand which parts of the input are more important for the classification. But in this case, for instance, we want to know which clients are mainly responsible for the given prediction. And based on there was a survey from Google where they have mentioned that it's an open challenge in federated learning, debugging, and interpretability, basically. So we propose this TraceFL. It's a neuron provenance technique, which basically tracks the contribution of each client to the activated neuron in a neural network. It consists of mainly 4 steps. I will go briefly on these steps, but you can read the paper or I can take questions if something is unclear later. So the first step is it's identify the activated neurons in the global model. And the second step is it use gradient to find the most important neurons among those activated neurons. And then in the third step, it's map the client's contribution to each activated neuron of the global model. And the last step is to basically rank the clients based on their total contribution. The first step, for instance, let's say if the neural network is using ReLU activation function, and if the output is greater than 0, it means the neuron is activated or it's taking part in the prediction. So what we do, we do not track the contribution of non-activated neurons. We only track the contributions in the activated neurons, which in this case are the green one. So by just focusing on the relevant neurons, we can avoid irrelevant attributions. Basically, we can minimize the noise. And in the second step, we compute the gradient of each activated neuron. And the key insight is basically if we compute the gradients, neurons with a small or 0 gradients have minimal impact on the output of the global model. And in the third step, we map the client contributions in activated neuron back to the global model. So for instance, as we know, this is the global neuron, and it's made up of the corresponding weights of each hospital weights or the client weights. And to summarize, there is a derivation in the paper, but I just want to skip it in the interest of time. That if we this equation basically tells us precise contribution of each client in this activated neuron. And in the final steps, we for each hospital, we compute the total contributions in all these activated neurons based on the step 3. And in the finally, we take the we normalize the attributions, and we take the basically softmax on this for each hospital based on their contributions. So this way, these steps. We aggregate all the contribution to each activated neurons to assign a responsibility score. And finally, we rank basically the from highest to lowest client based on their contribution to the given prediction. And in our evaluations, we used image classification datasets, medical imaging datasets, and text classification datasets. We use CNN transformers. We scaled up the clients up to 1,000. We sampled 10 to 50 clients per round. We used mainly Dirichlet data distribution, and we also ranges it from 0.1 to 1 to cover different data distributions. And in 12 different FL configuration, 400 FL rounds, we found that TraceFL is accuracy of localizing the responsible client for the given prediction is roughly around 99%. And we also tested it with differential privacy, and we have seen that it's also works the differential privacy, because in differential privacy we just add the noise to the weights of the models, and since the TraceFL works at the neuron level, so we found that it's equally effective at with the differential privacy. And to summarize, basically, it's the first interpretability technique in federated learning, which can give the precise contribution of clients for the given prediction. And it's compatible with any Hugging Face model, classification model, and also any flower data sets. And it's, So and the complete artifact is available in Flower FL. In Flower, we implemented in Flower FL, but we are currently in the process of making its baseline. So, and it's also received all these functional, reusable, and available badges for this paper. And thank you, everyone. If you have any questions, please ask.
Just one basic question is along the lines of an online person asked, is this easy to generalize to different types of hardware? And and the second follow-up question would be, is there any type of hardware support you wish you had access to?
If I understand it correctly, is there any hardware related constraint for TraceFL? Is that correct?
Yeah, I think so. Yeah.
Yeah. So we don't see any hardware constraint. It's even this artifact is completely available on Colab, so you can just run it on Colab, and we are running like basically training GPT-2 model on the Colab, and we are using this Flower FL framework for the training and to find the attribution of each client. So we are using TraceFL. So I don't see any hardware constraint. So there is no issue on that.
All right, thank you very much. We have another question.
I was wondering, can we track the contribution of different clients from the data distribution of each client? If we have access to the data distribution across different clients, can we track the contribution?
So that is a very good question. So if I go over here, for instance, let's say, let me go over here. So for instance, so in this case, for instance, I think this hospital 2, 3, and 4 are responsible for cancer related to cancer labels. Even we have access to these data distributions. When the global model makes this prediction, we cannot be sure whether it's hospital 2, hospital 3, or hospital 4. So this can still be a problem if we can have even access to their data distributions, because we want to see, for instance, is hospital 2 is mainly responsible, or hospital 3 is responsible, or even hospital 4 is responsible. So there still can be this problem even if we have access to precise data distribution across clients.
To the labels.
Does
How
it?
Do you, sorry.
Yeah. So, does it?
Yeah.
Can you please go?
Yeah. I was just wondering, do you have labels? How do you know how much is the actual contribution of different hospitals?
Yes. So because we have, since we are distributing the data, so we established that ground truth so that we know that, okay, these clients will be responsible for this prediction. So we have access to that labels, but in real world, when we deploy the system, we may not be able to access those label data distributions. But for instance, for our evaluation purpose, we need a ground truth to compute those accuracy numbers. So we have access to labels because we were distributing this data. But for the real deployment, we will not need those labels. It's just for the purpose of this evaluation.
Thank you so much.
You're welcome.
All right, so I think that's it. Thank you so much. And yeah,
Thank you.
Thanks again.
Thank you.